Hi everyone, this is a short video to explain the difference between electric field and electric force. So a pointed charge, let's say a positive pointed charge, creates an electric field E at some point here, let's say at this point, and the value of this electric field is K multiplied by that charge. Let's call that a charge Q. So E is equal K Q over R squared, where R is the distance between the charge and that point. And that point. So that's the magnitude of the electric field, K, an absolute value if you want, because we're talking about the magnitude, KQ over R squared. And the direction of that electric field, if the charge is positive, then this electric field is radially away. That's the electric field. It's radially away. And if the charge was negative, let's say the charge was negative. Okay, let's make it negative. Then, so it's minus Q in that case. So the magnitude is the same, but the direction of the electric field will be radially inward. That's the direction of the electric field. It's radially inward. So a pointed charge creates an electric field. Let's highlight that equation. Electric force, from the formula of the electric force, you require two pointed charges to have an electric force, Q1, Q2, over R squared. So we need two charges. Let's say I have a positive charge, Q, Q1. I have a negative charge, Q2. So Q1 exerts a force on Q2, which is going to be an attractive force, and it's equal to K Q1 Q2 over R squared. Again, R is the distance, as we have mentioned here. R is the distance, so here R is also the distance between the charges. And the negative charge will exert also an attractive force on the positive charge, which has also the same value F. K Q1 Q2 over R squared. So we need two charges to have an electric force, while we need one charge to have an electric field. And finally, there is this last formula, F is equal to Q multiplied by the electric field, if we are talking about vectors, which means if I have in space, in a region of space, an electric field E, let's say that's an electric field E in a certain direction, and it's represented by those arrows or vectors. That's an electric field E. And you place a pointed charge. Let's say I put a point charge here, a positive pointed charge. Then this electric field will create a force on that charge. So this electric field will create a force on that charge. And since the charge is positive, then the force is going to be in the same direction as the electric field. So an electric field creates a force on a pointed charge. And if the charge was negative, then the field will create an electric force which is equal to QE, but in the opposite direction of the electric field. And that's obvious from the equation, because if Q is positive, then F and E same direction. If Q is negative, F and E have opposite direction. Thank you for watching.